Okay, welcome to the first day of trigonometry. And so I wanted to start out with a basic introduction. You don't have this in your packet, but I wanted to help you with the basics so that we would make sure that we were all kind of on the same page. So here we have a right triangle introduction, and it says trigonometry means triangle measure. So there's a few things that I wanted to go over about this. So when I label the right triangle, so here's my right angle, typically you will see that it's letter C. And I want you to realize that I have capital letters A, B, C. They are the angles, while the sides opposite are labeled with a corresponding lowercase letters. So you'll see across from the capital C is a small c, across from capital B is a small b, across from capital A is small a. So I just wanted you to see how we label that. And the other thing I want you to remember is in a right triangle, we're able to actually call these the legs and the hypotenuse because that's only in a right triangle. And we also know the Pythagorean theorem that you all have learned from previously. So this is just stuff that you know. I just wanted to make sure that we were all on the same side about how we labeled it. So I like to label the angles on the outside, the angles on the inside. So I usually show an angle like this. I will arc it and talk about the angle here, or here's angle B. You'll see me do a double arc if I'm talking about more than one angle. Okay, so the hypotenuse is the longest side of a right triangle because it's opposite across from the right angle, which is your largest angle. So that's why it's the longest side. The legs, the shorter two sides, are opposite the acute angle. So angle A and angle B, those sides are going to be smaller, A and B, because they're going to be shorter because the angles are smaller. Adjacent means next to or touching. Opposite means across from. Okay, so when we label this, I always like to tell everybody to label it hua. So this is how I want you to label all your right triangles. So when you start saying hua, stands for the hypotenuse. And the hypotenuse is pretty easy because it's across from the right angle. No matter which way this triangle is lying, you can always find the hypotenuse and it's in the same spot. Okay, what is a little bit different is depending on the angle you're talking to. So right now, if I'm talking about angle A, if I was standing right here and I was labeling this hua, because I have to, the H stands for hypotenuse, O stands for opposite, A is for adjacent. You have to like put yourself here and look opposite. So your O would be here and what's left over is adjacent. Now, if I'm talking about angle B, which you have to then put yourself up here and look across, your O's and A's can switch positions depending on what angle you're talking about, but your hypotenuse never will. So right here, opposite angle B, if I was talking that way, it'd be O and A is this way. So it all depends on what angle you're talking about for your opposite or adjacent, but your hypotenuse will always be across from the right angle, okay? So now we're going to talk about some trig ratios. So we have three that we're talking about today. The main three is we have sine, and we're going to use theta as an angle. So we're going to use the angle theta. Sometimes you'll see an x, but when I say angle, I'm going to use a less than sign with the arc. Sine theta, cosine theta, and tangent theta. And they talk about the ratios. A couple things I want to remind you about. You can only use sine, cosine, tangent, and any trig function with an angle. They stay together. You cannot write it just as sine with nothing there. It doesn't mean anything. So here is how we'll let you do this, is you can write sine as sin, if you will. So we'll say sine theta here, cosine theta, and tangent theta. We'll see sine, cosine, and tan. We'll let you write it that way, but that's what it means, okay? And remember, this is a common mistake. You cannot write any trig function without the angle next to it. Okay, so the definition of sine is the opposite side. So this is where we get the O and H from. The opposite side over your hypotenuse. The cosine is your adjacent side over your hypotenuse. And your tangent is your opposite over your adjacent, okay? And that's, if they're talking about this angle right here, that's where they labeled everything, okay? So here would be your H for hua, opposite would be here, and adjacent would be here. So I know probably a lot of you know this. I just wanted to make sure that we were clear, okay? The hypotenuse is always the same, regardless regardless of which acute angle you label as theta. The adjacent and opposite sides will switch depending on the acute angle you label as theta. So that's what I wanted to tell you about. All right, so let's look at the next thing. So now we have this mnemonic device that we remember. We call it Sohcahtoa. I actually write it like this, okay? S with an O over H like this. So Sohcahtoa, okay? So the S stands for sine, opposite over hypotenuse. The C stands for cosine, which is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's what the T stands for. So I just wanted you to know this is what we're going to be using today when we talk about Lab 3, because we're going to talk about right triangle trig, and I wanted you to have these basics. So I'm not going to really worry about this right now, but I do want to have you see this. So I'm at the bottom here is talking about the angle of elevation and the angle of depression. So I want you to see these pictures here. I have this person here, and if this is their line of sight and they're looking at this light tower, the angle of elevation is the difference between the horizontal line and their line of sight. So the angle of elevation is always on the bottom, okay? It can be the other way, but it's usually the elevation of you're looking up, okay? The angle of depression is, here's somebody, they're looking at somebody swimming in the water. When they look, so here's their line of sight is this way. Excuse me, this is the horizontal line, I'm sorry. And they're looking down, and here's their line of sight. The angle of depression, do you see, is outside of the triangle. That's important for you to notice that, because the angle of depression equals the angle of elevation, because right here's an angle of elevation. If I'm talking about the swimmer looking up at the person that's the lifeguard, these are congruent, okay? So these are congruent because of alternate interior angles of parallel lines. So if they tell you angle of depression, you can always put it down here as angle of elevation because they are congruent to each other. So that is a little beginning part. So I want to now go into talking about the special right triangles, which I know you've already watched a video on this, but what I wanted to do right now was fill out the table. So I've got to find the table. It's here somewhere. I think I passed it. I know it's back here a little bit. Sorry. There it is. Okay, so we are going to put this on the back of our unit circle plate, but I wanted you to have the table here because you're going to need it for today's lesson. So the first thing is we're going to talk about the degrees, and I want to let you know that we start at 0. We're going to call that 360, and we're going to use 30 degrees, 45, 60, and 90 because these are our special angles we were talking about. When I get to here up to 90, right from here to here is quadrant 1, okay? And I call actually the 90-degree angle your quadrantal angle because that is right on one of the quadrants. The other quadrantal angles we have here are 180 and 270. So these are our quadrantal angles. And when you go to do what the sine and cosine are, we're going to base it all off the unit circle. So I'm going to draw that in a little bit. But first of all, let's do radians. So here, this is also 0 radians and 2 pi radians. Because when you switch from degrees to radians, pi is 180 degrees when it becomes radians. That's your conversion. I know that if I took pi and divide it by 6, or 180 divided by 6, that'd be 30. 180 divided by 4, that'd be 45. 180 divided by 3, that'd be 60. 180 divided by 2, that would be 90. And we can keep going down here. 180 would be pi, and 270 is 3 pi over 2. So there's the radian measure of the main angles. So I have my 4 quadrantal angles, and then I have quadrant 1, all right? So sine is our y part, cosine is our x. So sine of the angle is our y value, cosine of the angle is our x value, tangent is sine of the angle divided by cosine of the angle, or y over x, okay? So I'm going to go through and just do the quadrantal ones first. And when I do the quadrantal, I don't have a lot of room up here, so I'm going to kind of go down at the bottom here. If I had a unit circle, so I'll show you where the quadrantal angles come from. If I had a unit circle here, so I'm going to draw a nice, beautiful unit circle, a little lumpy. This is my point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So again, this is our 0-degree angle. Here's our 90-degree angle, our 180-degree angle, our 270. Okay, so if I want to know what the value of sine or cosine is, I know all the points are cosine of the angle, sine of the angle, or my x and y. So I can look at, we'll look at 0 here. I know the cosine of 0 is 1 because that's in the x value. The sine of 0 is 0 because that's the y value. So we're going to go through and actually put these in. The only thing that's weird when you put them in here is that they are backwards because I have my y's before x's. So the cosine, the sine of theta, if at 0 is 0, the cosine is 1 because it's the 0.10. When I go to 90, it's the 0.01. So that we're going to put it in backwards. 180 is negative 1, 0. 270 is 0, negative 1. So I just kind of put it in backwards because my y's and x's are switched. Okay, so we did the quadrantal angles. Now there's a pattern when I go through this because sine starts at 0 and goes up to 1. Cosine is at 1 and goes down to 0. There's a pattern that you can do. So watch, you got radical 1 over 2, radical 2 over 2, radical 3 over 2. And then this is the same thing but backwards. Radical 3 over 2, radical 2 over 2, and 1/2. Okay, so that's the pattern there. Now tangent is pretty easy because it's sine divided by cosine. So 0 divided by 1 is 0. 1 divided by 0 is undefined. And if you think of tangent as slope, if the line goes like this, it has 0 slope. That's why that's 0. 90 goes up, straight up and down. That has undefined slope. That's why it's undefined. Doesn't exist. 0 divided by negative 1 is 0. Okay, so there's 180 again. That's why it has 0 slope. It's 0. I always think of tangent as slope. And 270 goes like this, so it's undefined. Oops, sorry. Almost wrote 270 again. Undefined. Okay. Now let's go back up. Let's do tangent. So when I take sine and divide it by cosine, it comes out as radical 3 over 3. Radical 2 over 2 divided by itself is 1. And radical 3 over 2 divided by half is radical 3. So now you have all the exact values of the main angles that I want you to have memorized. And you're going to need to know this information to do the lab that we have for today. So I hope this helps. Please put these in your notes, in your spiral notebook so that you can have it to refer to, and we will be referring to it very often. So that's the end of this.